Hi everyone, welcome to my channel Code with GD. I am Gaurav and I have been working as a software developer since the past 5 years. I create videos to help you become a better developer. So without further ado, let's dive right in. So today we will look at the maximum sum subarray problem. So let's look at the problem statement. The problem statement states that if you are given an array, let's say I have an array 1, 1, 2, 3, 5, 4, and I am given an integer k equal to, let's say, 3. I need to find the length of the longest subarray such that the sum of the elements is equal to k. So let's first define what is a subarray. A subarray is a group of continuous elements in an array. For example, here 1, 1 and 2 are continuous, so it is a subarray. Similarly, 2, 3, 5 can also be a subarray. 1, 1, 2, 3 is also a subarray. So what is not a subarray? Let's say we take elements 2, 5 and 4. These are not continuous, hence it is not a subarray. Group of elements like 2, 5 and 4 is called a subsequence, but it is not a subarray. All subarrays are subsequence, but not all subsequence is a subarray. Now let's look at the problem statement. So we are given k equals to 3 and this array. First, let's look at the brute force solution. In your actual coding interview, this question won't be named as max subarray with some k. They will make up some story. For example, this question was asked in Google as per this lead code post. There the question was, you are given an array of prices of different ice creams, but your wallet has a budget dollars. Find the length of the longest subarray whose total price is equal to budget. So at that time you need to relate that, okay, this is a maximum subarray question. So for example, as per this question, this is an array of prices of ice cream, and this is the amount of money in your wallet, and they were asking maximum number of ice creams that you can purchase. So money is k and individual elements are ice cream and the element value is price. So they were asking maximum number of continuous ice creams that you can purchase. And making stories in interview questions is very common. You will find a lot of interesting stories there. Anyways, let's start with the solution. Brute force means the basic solution, like the solution in which you don't need to apply any logic. Without applying any logic, just take the easiest possible way to solve the problem. The easiest way to solve this would be go through each array. So my array elements are 1, 1, 2, 3, 5 and 4. Go through each subarray. For example, this is a subarray. 1, 1 is also a subarray. 1, 1, 2 is another. Go through all the subarrays and find the sum of each of these subarrays, and then compare. If the sum is equal to k, then find what is the length of the maximum such subarray, and that will be the result. So how would this work? Let's see. So for this, I can create a loop, for loop. Let's say I have I equal to 0 here. This will go till I less than n, I plus plus. Inside this we can have another for loop where this for loop goes from j equals to I till j less than n. So this way, in the first iteration, I is 0 and j is I. So this will be one subarray. In the next iteration of the inner loop, j will be 1. So j will come here and we will go through another subarray 1 and 1. Similarly, this will continue till j is n. So the next subarray we will look at is this. So we will add 2 plus 1 plus 1, 4, that is not equal to 3. So let's move to the next subarray. Similarly, we will traverse this entire array starting with starting point as the 0th element. Next after this for loop ends, we will come out onto this for loop. Now I is 1. So I will bring, so now I is here. Then j is I, so j is also here. And 1 is it equal to 3? No. So then j moves to this. 2 plus 1, 3. Yes, j is equal to 3. So we store somewhere, we store as result as maximum length is 2. Then we again check this array and again this. We do this till j is less than n. Again we repeat this entire process for I equals to 2, 3, 4 till n. So we make subarrays like this, then starting from this, all the combinations. So how many combinations do we have here? We have order of n square combinations, and that is how many times this loop will run. So our time complexity will be order of n square for this approach. And talking about space complexity, since we are not using any extra space, our space complexity will be order of 1. Now let's code for this. So I will find int n equals nums dot length. I will create a variable int max length subarray equals, I can initialize it with 0. Now we will run a for loop for int I 0, I less than n, I plus plus. After this I will initialize a variable sum is 0. This is the sum. So when I starts from 0, we have our initial sum as 0. After this we create another loop for int j, which will start from I, j less than n, and j plus plus. So this j is our end element of our subarray. So initially both of them will point to the same element, and then we will add the element to the current sum, and then we will check if sum is equal to our k. If sum is equal to k, we will do a comparison, which is our max len subarray. Okay, so here we compare the sum. So what will be the length of the subarray whose sum is k? It will be j minus I plus 1. So for example, I was, let me write here. Now for example, I was 0 and j was 1. The length of this is 2. So we can write the formula as j minus I j minus I plus 1. So is the length of current subarray maximum, or the length that we had previously stored, that is more? So this function will compare and assign the value to max length subarray. So after this loop finishes, we can return our result, return the length of the maximum subarray. This is actually sub. In most practical cases, this won't run. Like if you're giving an exam or it is a coding round, they will add a time limit error in case you try to run the solution. Or if you are giving an interview, the interviewer will ask you to further optimize the solution, since this is the most basic solution and they want you to have a better answer. So let's look at a more optimal approach. A more optimal approach involves hashing. So I'll write here optimal approach 1, because after this there's a more optimal version of this approach. I will tell you limitations of both. Let's look at the second approach that makes use of HashMap. Now I have this array 1, 1, 2, 3, 5 and 4. This solution will also require a basic mathematical operations, addition and subtraction. For this we will create a summation array and store the sum of the array as we traverse. So sum till here will be 1, sum till index 1 will be 2. Similarly, sum till index 2 will be 2 plus 2, 4. This is my summation array. Sum till 3 will be 7. Sum till this index will be 12. And sum till this index will be 16. Now if we want to find sum of any elements of the subarray, for example, if I want to find the sum of these elements, I can simply take the sum till here and subtract this total summation till here. I have summation of 12 till here minus we had summation of 2, which will give us 10. Now we can calculate the sum of actual elements. 5 plus 3 is 8 plus 2 is 10. So this way we can find sum of any subarray using this summation array. In our case, we are interested where the sum is equal to k. Now let's say we are at element, let's say 2. Now we are at 2 and we need to find a subarray such that it ends at this index and the sum of the subarray should be k. Now if this is, let's say it wants to be a part of subarray, the sum of remaining elements of the subarray should be k minus 2. Now we can easily find it. So k minus 2 will be, in this example, 2 minus 1, which is 1. Now we will go to the summation array. Is there any element where the sum is equal to 1? We find yes, it's here at position 0. So we cut the array from here and this is the end, and this is the resultant array, one of the subarrays whose sum will be k. We can have multiple such combinations, and for each of these we have to search in the submission array and find the index, and from that we know the length of the subarray. For example, here the end index was 2 and the index from where we want to start the subarray is 0. So 2 minus 0 gives us 2, which is the length of the subarray. Now how do we search in the summation array? Well, for that we can't use an array. So searching in a map is easier than searching in an array. So we store all of this in a hash map. Our hash map can look something like this. We can store sum and the index. As we traverse through the array, let's say we are at 2. Now from this we need to search the position where summation is 1. So we search in the hash map and we find, okay, 1 is at index 0. The other values will look like 2 will be stored at first, 4 will be at 2, and so on. There are some edge cases that we need to take care of. So for example, we have the array something like 1 1 2 0 0 and then we have 3. In this case, our summation array, not summation array, now we are maintaining a map. So our map will look something like, we go to 1, okay, we have a sum is now 1 and it is at the 0th index, so we store 1 for 0th index. Next we go to the second element, our sum is now 2 and we store it in the first index. Then we go to the third element, sum is 4 and we store it in the second index. Next, when we reach here, we are adding 0, so our sum is still 4. Now in map, if we want to enter it, it will update the second index to 3. Now question is, do we want this? Now we generally search in the map when we want to look for the starting point of our subarray. If we keep on updating this map with newer indices, our length of the subarray will keep on reducing. So that's why we don't want to update this in case the sum is already present. So when we reach here, we see that the sum is 4. We search in this map, we see that is 4 present, we get yes. So don't update the map, move to the next element. We see 0 and sum is still 4, don't update, and so on. Now this approach also works for negative numbers. Let's code for it. Int is nums.length. We have int max is 0. Now we will declare a map. Integer. Now let's traverse through the array. We will also have a variable sum equals to 0. This sum is this sum. After we reach, we will update the sum plus equal to nums of I. Now if sum is k, so if sum is k, it will mean the starting point is 0, since the sum is the sum of all elements from beginning. In that case, we will check for max is math.max. What is more, max or the length of the array traversed till now is I plus 1. Now in case sum is not k, we want to find k minus the current element, which is like our target, k minus nums of I. We will search in the hash map if this is present, and target index is, I will name this index map. Get by default target. If target is not present, I will return -1. Now if target is present, greater than 0. If target index is greater than 0, I know the starting of the subarray is after this index. In that case, my length of the subarray is current index minus this target index, since the element in this target index is not included. So I have the same logic. And this will be I minus target index. Now we also want to add this index in the map, the current index, along with the sum. So for that, I need to check if the current summation is already present in the map. So I will have index some index is index map dot getter default sum and minus 1. Now if this current sum index is not present, then this function will return minus 1, and we have current sum index. In that case, we will save, I'll put our sum in the map. Dot put, and I will write sum and current index is I. At the end, I will return max, and that's my answer. This is what the whole code looks like. You can pause and take a screenshot if you want. Now, what will be the time complexity and space complexity of this solution? Let's look at that. Since we are using a map, and what will be the number of elements in this map? Okay, we are using a map. The number of elements will be n, where n is the length of this array, and if all the elements are distinct, all the elements will be inserted to the map. So, and we are creating a whole new map, so the space complexity will be order of n. Now what will be the time complexity? As you can see the code, we are traversing the array only once. We only have one for loop here. Hence the time complexity will be big O of n into, at every index we are searching for the element in the map. Now the quotient here will depend on the search complexity of the type of map we are using. So if we are using an ordered map which stores everything in order, the search complexity is order of log of n. If we are using an ordered map, in most cases search complexity will be order of 1, but the worst case time complexity will be order of n square. Now this will be an edge case. This is because of the way unordered map stores its element. So the time complexity will be order of n log n in case we use an ordered map, and it will be order of n in case we are using unordered map, and worst case would be order of n into n square, which is order of n cube. So this is related to time and space complexity of this approach. Now the problem with this approach is we are using extra space to solve it. Now is there a way where we can solve this without using this extra space? Yes, there is, and that is called the two-pointer approach, where we make use of 2 pointers, one at the start, one at the end, and then it keeps on. It's more of a sliding window where the window keeps on sliding, and we compare all the possibilities. of the summations and we do our calculations as we traverse the array. Let's look at it. Yeah, now we are on to our third optimal approach. Now this was HashMap and this is 2-pointer, or we can also call this sliding window, since we define a window and we keep on shifting it. We have the array 1, 1, 2, 3, 5 and 4. We declare 2 pointers I and j. So I will be the starting of our sliding window and this will denote the end of the sliding window, and this will be start or beginning of. Now we start from beginning. Both I and j point to the first element. This is our window. Now we calculate the sum. So we will have a global sum variable. It is now equal to 1. Now we check 1, is it equal to 3? No. Then we check if sum is less than 3. Yes, sum is less than 3. So we need to increase our window size. So we update j to point to the next element. J will now point here, and now our window becomes this. Since we increased j by 1, this new element was added to our window. So we add the value of this new element to sum, which is now equal to 2. Now we check, is sum less than k? Yes, sum is less than k. We again increment j to come here and we increase our window, and since this new element 2 was added, we add it to our sum and this now becomes 4. Now we check, is 4 less than k? No, 4 is not less than k. So we increase the starting point of our sliding window. Now if we increase this I and point it to the next element, our window size will decrease and so the sum will also decrease. So when I goes to the second element, our window looks like this. And this means we have to subtract this I from our sum, which will give us again 3. Now we check and we see that sum is equal to 3. So we do our computations. We will have a global max len variable and we will find the length of this subarray, which will be j minus I plus 1. Since like j is pointing at the second index, I is pointing at the first index, 2 minus 1 and plus 1, like the length of this is 2. So j minus I plus 1, and at this point we will use max of current max and j minus I plus 1. Now we repeat this process every time we increase j, only if the sum in the sliding window is less than 3. Once the sum reaches 3 or is more than 3, we increment I so as to decrease the sum present in the sliding window. Now this approach works fine. In this you can see that we are using no extra space. So space complexity is order of 1 and time complexity is order of n, since we are incrementally increasing I and j. So in the worst case, j will traverse the entire array only once and I will also traverse the entire array only once. So both of them will travel the array twice. So we will have order of 2n time complexity, which is equal to order of n. Hence, this is the time and space complexity. But this solution comes with its drawbacks. One of the drawbacks is the solution doesn't work for negative numbers. So if your array has negative numbers, it won't work. It is because of the way the sliding window is designed. You can check your own example to see that it doesn't work. For example, you can introduce a series of minus ones and minus twos and zeros, and you can go through a horizon and check. Anyways, the solution works only for positive numbers. So if you're asked this question in your interview, you can tell this approach and also list the drawbacks, and you can also code for it. Now let's code for this. By the way, if you want to solve it for negative numbers, the previous approach where we had used hash maps, that works the best. I will reset this. I have n is nums.length. I will have 2 pointers, and I, so I will be a starting pointer. It will point to 0, and j will point to the end of the sliding window, which will also be 0. And we will have a sum, so we initialize our sum with the first element, which is nums of 0. And now let's write our while loop. So for our while loop, we will have the end of the sliding window. It should go till less than the length of the entire array. Inside this while loop, we will write another while loop where I, it should be less than j, and this I should increase only if sum is more than k. So you can see here, we were incrementing I only if sum was more than k. If sum is less than k, we want to increment j. Now we write the code for it. For this, we will reduce the element at the ith position from the sum. So sum is sum minus equals to, which is equivalent to sum equals to sum minus nums of I. So we first reduce sum, then we increment I. So now the overall effect will be the sum of elements in the sliding window will decrease. This is because we are decreasing the number of elements. Now if sum is equal to k, we will write our max logic, which is max. My max will be equals to math.max, and maximum of the already stored max or the new length of the sliding window, which will be j minus I plus 1, which we saw here. So this step, if sum equals to k, we do this. Now we did the step where we increment I in case sum is more than k. We also handle the case where sum is equal to k. What is remaining is if sum is less than k. We don't need to specifically write a condition for that because the other two are already covered above. So for that, we will increment j, and then we will increment the value of sum. So we will write sum plus equal to nums of j. Now this is our final code. We can safely return max, and this is the solution. For those who don't know, sum plus equal to stands for sum equals sum plus nums of j. Similarly, this means this is a short form of writing sum equal to sum minus nums of I. So that's all for this video. Thank you for watching. If you liked the video, hit the like button and share this video with your friends. Subscribe to my channel Code with GD. Till then, happy coding. Bye bye.